So next we're going to learn how do I name an acid. So one thing you'll notice that's in common with our acids is that they're all going to have a hydrogen in them. And we'll learn there's a reason for that. We're going to learn a lot more about acids in our unit where we talk a lot about acids and bases, but that's one thing that's in common for all of our acids. But there's sort of two different classes of acids you can look at, those that contain oxygen and those that do not contain oxygen. So we'll start with the ones that do not contain oxygen. So if you see a hydrogen bonded to a chlorine, that's an acid. And the way that we name it traditionally is by replacing the word hydrogen with hydro. And then instead of saying chlorine here, we're going to change the ending to ic acid to tell everybody that this is an acid. So instead of hydrogen chloride, like we might name it as an ionic compound, we'll say hydrochloric acid. Or here we have a hydrogen bonded to a fluorine, so we'll say hydrofluoric acid to tell everybody it's an acid. Here you see there's actually two hydrogens bonded to a sulfur, and you might think, oh, do I have to do something fancy with that too? No, you don't. That too just comes out of the charges, right? A hydrogen wants to give away one electron, leaving it with a charge of +1. Sulfur wants to gain 2 electrons, get a charge of -2. So because of those charges, I'm going to need 2 hydrogens to make that sulfur happy, right, for every 1 sulfur. So that H2S is just given by the charges. You don't have to do anything fancy in the name to show everybody that. So that means your name will be just the same. You'll say hydro, and then sulfur, indicating the sulfur, and then ic acid. So 2 hydrogens bonded to a sulfur is hydrosulfuric acid. Here's a whole bunch of them. So HF we said was hydrofluoric acid, hydrochloric acid is HCl, HBr, well that'll be hydro, brome, and then ic acid, same pattern. HI is hydro iode, and then instead of the full word iodine, we cut it off and say iodic acid, hydroiodic acid. This one's fun. This is actually a polyatomic ion sneaking in there. Cn, -1 charge, that's cyanide. That's your polyatomic ion there. And when you stick a hydrogen in it, it becomes an acid. So we have hydrocyanic acid. So again, that pattern of hydro and then ic acid. We take off the ending of cyanide and just say cyanic acid, and hydrosulfuric acid that we saw before. So that's the traditional way of naming acids that do not contain oxygen. But actually, IUPAC has updated that naming system too. So this is another case where we have to learn 2 different naming systems, the traditional manner, so hydrochloric acid, hydroiodic acid, and then the new IUPAC name. The new IUPAC name is simpler, which is kind of nice. We name it just like we would any other type 1 ionic compound, but to show everybody that it's an acid, we stick the word aqueous in front. So here we have hydrochloric acid, HCl. We're going to name that like an ionic compound. We call it hydrogen chloride, right? It's a hydrogen bonded to a chlorine. That's true. The only change is we change the ending to "ide" to show that it's an ionic compound, hydrogen chloride. And then, because we want to tell everybody this is an acid, we tell everybody that by putting aqueous out front. So aqueous hydrogen chloride. Or here's HF. Well, that would be hydrogen bonded to fluorine. So we could say hydrogen fluoride, just change that ending. And then to tell everyone it's an acid, we stick aqueous out front. 2 hydrogens bonded to a sulfur, well, that would be hydrogen sulfide, note that new ending. And we'd stick aqueous out front to say this is an acid. All right, so that was acids that do not contain oxygen. The next type of acid is called an oxo acid, and that's an acid that does contain oxygen. And you'll notice that actually all of these guys come from your polyatomic ions over here. Because your polyatomic ions, you probably noticed when we were making them in class, we used a whole lot of oxygen, right? There was tons of oxygens out there. A lot of our polyatomic ions have oxygens, and that shows up in our oxo acids. So in this case, there's only one way to name them. So there's not like an old and a new version. There's just one way of naming oxo acids. And how it works is we replace the ending with something that indicates it's an acid. So you have different types of endings to your polyatomic ions. Some of them end with an 8, right? If you have something like nitrate, that ends in ate. So notice NO3 is nitrate. So this first example is a hydrogen bonded to a nitrate. This is, nitrate. There we go. Hydrogen bonded to a nitrate. If you see an ending 8 in your polyatomic ion, we're going to replace that ending with ic acid. And we don't have to write down the hydrogen at all. We know there's a hydrogen there because it's an acid. So if we say nitric acid, you know that that's a hydrogen bonded to a nitrate. The acid part is what tells you there's got to be a hydrogen there. Now, how in the world do I remember that I'm going to replace all the polyatomic ions that end in 8 with ic acid when they become an acid, when they gain that hydrogen? Here's how I remember it. If I ate something I didn't like, perhaps an acid, maybe I don't like acids, then I'd probably say ick. Maybe I'd even say ick. It's an acid. You know, like this is really terrible. Ick acid. So that's how I remember that things that you ate, we might say ick to. So a nitrate, when we bond it to a hydrogen to make nitric acid, or here's a sulfate, right? SO4 is sulfate. We bond it to hydrogens, and here you're going to need 2 of them, right? Because sulfate has that -2 charge. You don't have to indicate the 2 in the name, again, right? It all comes from the charges. Well, that sulfate is now going to become sulfuric acid. We say ick to things that we ate. Or here is acetate. So this is another one of your polyatomic ions, acetate. If I want to make it an acid, then I just have to bond in a hydrogen, and it'll become, instead of acetate, acetic acid, so ic acid at the end. So that's for all of the polyatomic ions that end in ate. What about all the ones that end in ite? That is what we'll do next. So if they end in ite, then we change the suffix to us acid when you bond in that hydrogen to make it an acid. So let's say you start with nitrite. That's what this NO2 is here. So I keep writing M instead of N's. Nitrite. So it has an ending of ite. We're going to replace that nitrite, that's the NO2 part here. We're going to replace that with nitrous acid when we stick in that hydrogen there to make it an acid. I don't have a great way of remembering this. I'll tell you what I do. You probably will come up with a better way. But I remember that night, and I'll spell this intentionally wrong, night lights are for all of us, and us rhymes with us acid here. So ite makes me think of all of us, because we all need night lights. They're just great for everyone. I don't know if that works for you. Maybe you don't like night lights. Maybe you can come up with a better way of remembering that any polyatomic ion that ends in ite, when it becomes an acid, we're going to call it an us acid. So nitrite becomes nitrous acid. Sulfite, right? SO3 here is sulfite. Well, that'll become sulfurous acid. Or chlorite, here's chlorite, ClO2. If we bring in a hydrogen to make it an acid, it'll become chlorous acid. And that's how you name your acids that contain oxygen, which are bonded to H's bonded to polyatomic ions that end in ite. Here's a few examples just to look at them. So here we've got nitrate. So we're going to call it nitric acid. Here I have a nitrite, so it's nitrous acid. Here's sulfate, so it becomes sulfuric acid. Here's sulfite, so it becomes sulfurous acid. Here's phosphate, so it becomes phosphoric acid. And here's acetate, so it becomes acetic acid. All right, that was a lot. So let's use a flowchart to try and kind of keep track of what do I do. The first thing you want to look at is, does your acid contain oxygen? If it does not contain oxygen, then the traditional way of writing down the name of that acid would be to say hydro plus the root of whatever the nonmetal is, whatever the anion is, and then ic acid. So for example, HCl is going to be hydrochlor, and then instead of ending with the chlorine here, we're going to say chloric acid. And that's for everybody that does not contain oxygen. The other way that we could write it, the new way that we could write down these non-oxygen containing acids, is the IUPAC way, where we say aqueous. So aqueous, and then we write down HCl just the way you would name it, as if it was a normal old ionic compound, right? Hydrogen bonded to chlorine, hydrogen chloride. So aqueous hydrogen chloride is the new way. Hydrochloric acid, oh, I forgot an O in there. Hydrochloric acid is the old way. So that's if it does not contain oxygen. If you look at your acid and you say, oh, yes, it does contain oxygen, then we're going to go this way. We have to check the ending of the anion. They're going to be polyatomic ions, and so they're going to end in "ite" or "ate." If that polyatomic ion ends in "ate," then you're going to replace the anion or element root with ic acid. So if you have something like HNO3, this NO3 is nitrate here. Then we're going to change that to make it an acid. That will become, I'll just bring you down here, nitric acid. So acid. So we take off the 8 and replace it with ic acid. And you can remember, if you ate something you didn't like, then you'd say ic, it's an acid. All right, if the ending is ite of your polyatomic ion, so maybe it's something like this. You have NO2. So NO2 is nitrite. Then when we stick in the hydrogen to make it an acid, it'll become nitrous acid. So if the ending was ite, you replace it with us acid. And I remember that by night lights are for us, with the OUS instead of just a US. And that is how you name acids.